In problem 14, we're going to solve a series of exponential equations by graphing using the graphing intersection method on our calculators. And the trick with these problems is in finding the correct window, because the intersection of our graphs needs to show up in our graphing window in order for the calculator to accurately determine the intersection. So let's see how this works for part A. So I have the equation 50 equals 25 times 1.15 to the x, and I want to solve that. So what I'm going to do on my calculator is let y1 equal 50 and y2 equal 25 times 1.15 to the x. Now, it doesn't matter which side you let be y1 and which side you let be y2. I just have a tendency to make the left side y1 and the right side y2. So now I'm going to enter my equation, and I need to get my exponent here to the x power. Now, if you're not sure what the proper window is going to be, you can always just go for the standard window, zoom 6, and see what happens. So in this case, what we see is that the exponential function, that's the one that was graphed here, because y1 is going to be a horizontal line that goes through y equals 50. So that's happening somewhere out of the screen area. So what I want to do is to change the window so that I can see where the intersection is going to take place. So let's look at the window that I have. I'm going to leave negative 10 to 10 to start with, and hopefully that's going to work out for x min and x max. I'm going to change my y min to 0, and in fact, I'm going to do that for all of these because I don't care about negative output values. I know that my output has to go up to at least 50 in order to see y1, so I'm going to go ahead and just make it 75 so that I get a better image and I'm not kind of squishing that output too close to the top of my screen. So I'm going to try this window, and I'm going to press graph. So there's the y equals 50, here's the exponential, and that is a really, really good graph. So what I'm going to do is I'm going to run my intersect process. So second calc number 5, and I'm going to press enter 3 times to get the intersection. Then I'm going to go ahead and record all of that information here. You might want to pause the video so that you can do that as well, and then check the answers, how it's presented on the page once you restart the video. So what I've done here is just transcribe the graph, the intersection, the window values that were selected, and then the final solution, x equals 4.96, which is rounded to 2 decimal places. So I'm reading this value from the x value of the intersection over here in my graphing window. Let's try part B. Now we're going to solve 250 equals 25 times 1.15 to the x. So what's happening here is that this part is the same for y2, but y1 just got a lot bigger. So I'm going to say that certainly my y min value is going to still be 0. My x min, I'm going to leave it at negative 10. I'm going to make x max bigger, because if y max is bigger, then chances are x max is going to need to be bigger. But let's see what happens with our graph. For y max is going to need to be at least 250, so I'm going to make it 300. And I'm going to go ahead, just for illustration purposes, and stick with an x max of 10, and let's see what happens. So don't be afraid to just try things. The worst thing you can do is just sort of randomly change all of your window values, or use one of the zoom windows that gets really big and you don't really know what's happening on the calculator. So I've changed my y1 to 250. Let me go to my window. And again, I'm going to go ahead and leave x min and x max, y min, y max I'm going to change to 300. And I'm going to press graph, and then let's see what happens. So there's the We're getting the y1 equals 250. Here's the exponential. Oops, my intersection is going to happen somewhere over here off the graphing window. This graphing window goes to 10, so I need to extend my x max so that I can see where the outputs are going to intersect with y equals 250. So I'm going to go back to my window and I'm going to change x max to 25. My standard approach is to start at 10. If 10 doesn't work for x max, I go to 25, 50, 100, etc. So here's the graph. There's y equals 250. Here comes the exponential. There, we can see our intersection. So we need to change our x max value over here, not to 10, but to 25. Now let's run the second calc, intersect, and determine what our solution is. Our solution then for x is 16.48. You might want to pause the video so that you can transcribe your graph here in this window and then come back and double check your results. So all I'm doing here in the graphing window is drawing the vertical axis. The horizontal axis is just this line right here. So transcribing the exponential part here, the horizontal line, and where they intersect. So let's take a look at the last one. 5 equals 10 times 0.86 to the t. So this function is a decreasing exponential function. And again, when in doubt, go ahead and just use your standard window values, negative 10 to 10, negative 10 to 10. Let's try that for this set of functions here. I'm going to change y1, I'm going to clear that out, make that 5. Go down to y2, clear that out, and make that 10 times 0.86 to the t. Now, zoom 6 will get me to that standard window, and let's see what happens. So there's our output of 5. There's our exponential, and that actually looks really good. I can see my intersection here, so I can run the second calc 5 intersection process and determine the intersection. The solution then, rounded to 2 decimals, is t equals 4.60. So this window is going to be fine. You might want to pause the video to transcribe your graph and then see what I come up with on mine. So all I did was to transcribe the graph here. I went ahead and put in a full axis because we decided to use negative 10 to 10 for y min. In these other graphs, we started with y min equals 0. Either way is fine. And then the intersection, 4.60, 5, gave us a solution of t equals 4.60.